Let's write the chemical equation for this reaction and then balance it. I'll highlight the terms that lead to the formulas and symbols in the equation. So a student suspends a copper wire, which is Cu, and that's a solid. And that's going to be in a aqueous solution of silver nitrate. So silver is a metal with a 1 positive charge, and nitrate is a polyatomic ion with a 1 negative charge. And those charges are going to cancel out, and this is going to be a 1-to-1 ratio. So that's the formula for silver nitrate. And because we're told that it's in solution, we can put AQ, which means it's dissolved in water. Now the students notice a deposit of silver crystals on the copper wire when it's reacting. So silver is forming and silver crystals. So that's solid. And I threw this in here for now because we haven't gotten to the point where we can predict the products, but we'll get there soon. So in other words, on some of these questions, we'll give you the reactants and you'll predict the products. You'll predict this side. All right, but I'm giving it to you now. So the other product is copper 2 nitrate. Now copper is a metal that can form multiple cations. So we're going to give you that charge to determine the formula. So this copper forms 2 positive cations and nitrate is NO3 with a 1 negative charge anion. So you can crisscross these numbers to get the formula. So the proper ratio that we'll need is a 2 nitrate to 1 copper cation ratio in order to make this ionic compound neutral. It should have a net 0 charge. Now, this is also in solution. So you'll know this by the end of this chapter. But the primary skill here we want to focus on is balancing the equation. On the left side, I see a copper, and I see one of those. I see silver, I see one of those. And the polyatomic ions on our test, and in this chapter at least, they're not going to change from the reactant side to the product side. So you should keep them together because it's not, NO3 is going to be always NO3 in this reaction. All right, so don't break it up in N and O. Keep it as NO3. Make life much easier when you're balancing this out. There's 1 nitrate. Now, on the right side, I'm going to write them in the same order. I'm not looking at what I see up here because I prefer to compare side by side. There's one copper, there's 1 silver, and there's 2 nitrates. That subscript tells you there's 2 nitrates because it's outside the parentheses. Right? It doesn't apply to copper because copper has its own subscript of 1. So now I'm looking at my work and I can see the nitrate is the problem. It's violating the law of conservation of mass. So I need to go to the reactant side and multiply where I see nitrate. Right? I can't do it right. I can't squeeze coefficients in between formulas. I see that sometimes too. You can only put them at the beginning of each species. So I need to put a 2 there so I can get 2 nitrates going. But don't forget to update the silver as well. So now I have 2 silvers. So I need to go back to the product side and update my silver. Multiply that by 2. So everything is balanced. And if you want to put a 1 here, we don't do that, but for this chapter, you can do that. And that's our balanced equation for this reaction between solid copper and a solution of silver nitrate. By the way, this is also known as a single replacement reaction or a single displacement reaction.